In this example, I need a velocity model that is constant for the top and the base of a sequence, and smoothly increases down the sequence. Due to lateral variations of the top and base horizon, this will create proportionally varying velocities across the sequence. Create a new volume maths process. Select a volume to quickly define the geometry. Enter the formula for the water layer, a constant 1500 meters per second. Set the volume class to interval velocity and adjust the min-max range to see the results. To create additional layers, add the required boundary horizons. Then use add and type the next formula. This equation is a little bit more complicated. Between the two horizons, calculate the ratio of the current time sample, TWTMS, to the total interval, giving a value from 0 to 1. This fraction is multiplied by the increase in velocity for this layer, giving a linearly increasing velocity through the layer. The min or minimum function limits the scalar value to 1 or lower. This stops the velocity from increasing after reaching the bottom of the layer. The max or maximum function limits the scalar values to be greater than 0. Above this layer, the function will not affect the velocity. Together, the min and max functions limit the scalar from 0 above the layer to 1 below the layer. So far, my model starts with a constant velocity layer of 1500 meters per second. The first horizon marks a velocity change, linearly increasing from 1500 meters per second to the next horizon, where it reaches 3000 meters per second. This value extends to the base of the model without increasing. Use add to include additional layers, using the same approach, updating the formula to use the next horizon and the minimum and maximum velocity. Finally, create a layer to define a velocity that increases from the deepest layer to the maximum specified time. This complete model begins with a constant velocity layer of 1500 meters per second. At the first horizon, the velocity increases from 1500 to 3000 meters per second. The second horizon marks a velocity change that increases to the next horizon, where it reaches 4500 meters per second. The final layer smoothly increases until reaching 6500 meters per second at a defined base of 6000 milliseconds. The final result is a detailed velocity model that compiles with structure and varies proportionally at different rates. If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight!